Good morning, welcome to our physics lesson today. My name is Nicholas Okuthe. In our previous lessons, we've been dealing with the topic quantity of heat, and specifically we last looked at evaporation. And the last part that we actually looked at was differences between evaporation and boiling. And we learned of the three differences, where we say evaporation takes place at all temperatures. Whether the temperature is at 30, 40, 50, evaporation will take place, but boiling will take place at a fixed temperature, which we call boiling point. So boiling point is a fixed temperature. Before a liquid reaches that point, it will never boil. Number two, evaporation takes place on the surface of the liquid, and this is why surface area affects evaporation. So the wider the surface area, the higher the rate of evaporation. But then boiling takes place throughout the liquid. If you recall what we studied in Form 1 under boiling, when we test boiling water by pouring or putting some potassium permanganate in the water, then it is boiled, then the potassium permanganate is seen to be moving in the direction that is almost throughout the liquid, what we call the convectional currents. Lastly, decrease in atmospheric pressure increases the rate of evaporation, meaning the lower the atmospheric pressure, the higher the rate of evaporation. But then in boiling, decrease in atmospheric pressure lowers the boiling point. So the lower the atmospheric pressure, the lower the boiling point, and the higher the atmospheric pressure, the higher the boiling point. So we want to go further and look at what we call applications of cooling by evaporation, and we only have two areas that we want to look at. One is sweating. Sweating is a way, or is a process by which our body gets rid of waste materials, especially urea and waste waters. So evaporating sweat normally absorbs latent heat of vaporization from the body, therefore creating a cooling effect. So when you sweat, then your body becomes cool, and sweating only occurs where the temperatures are very high. So the body responds by losing heat. So this heat is lost by water. Water from the body absorbs the latent heat of evaporation and evaporates with it. So that latent heat, when lost, then the body remains cool. You've seen animals like dogs always sweat by sticking out their tongues. Yeah, animals like cows, they sweat by having some moist part of the mouth, we call it the muzzle. Yeah, then human beings normally sweat by through the pores on the skin. So those are just various ways. So maybe you may be asked why a dog sticks out its tongue after maybe running or undergoing some strenuous activity. It is a way of cooling itself, because through that sticking out of the tongue, you'll see water dripping out from the tongue. Number two is cooling water in a porous pot. This is a traditional way of keeping cold water at homes, and it's still a practice that is used up to now. Yeah, when you put water in a porous pot, then what happens is that water will seep out of the pot through the pores. It is a porous pot, meaning it has pores on it. So water seeps out through the pores or the small holes, then evaporates from the surface of the pot. In the process of evaporation, they evaporate after absorbing latent heat of vaporization from the pot and the water. So in the process, they create a cooling effect in the porous pot, making the remaining water inside the pot to be cold, colder than the room temperature. We look at this. This should be an application of evaporation by cooling. Yeah. And a refrigerator, what sometimes we call a fridge, uses the principle of evaporation to cool or keep food items stored in it cold below some temperature, and in that way it's able to preserve food items for long. If you look at the parts, we have the insulation. The outer cover normally is an insulator, and you'll find maybe it's made of plastic or rubber and sometimes painted properly, so you may not really feel it well. Then we have what we call the evaporation pipe there, and if you look at that pipe is coiled. Yeah, the evaporation pipe here and the condenser pipe here. The coiling normally is to increase the surface area exposed, like here for heat loss or to emit heat, here also to absorb or to lose heat. There is the compressor pump. The compressor pump is able to pump the liquid, this liquid that flows around. So that is its major function. So there is normally the copper fins here that are able to absorb heat and remit it away. Yeah. So the copper fins normally are able to, or are used to help it in losing heat. Now heating from that surfaces, you know, when you put in a cold, this is like the door. So from the door there, heat may get in, or when you put a food item, the food item is at a slightly higher temperature. So heat enters through that point. So once inside there, then it's able to remain cold. Now, in the refrigerator, there's normally the lower compartment, then there's normally the freezer. Yeah, so we'll see how that works. Look at this. It consists of highly volatile liquid. So that liquid that flows inside it is a volatile liquid. A volatile liquid is a liquid that evaporates easily, and in this case we normally use a substance called freon. So freon absorbs latent heat of vaporization from the food contents inside the refrigerator and evaporates. So because it's volatile, it evaporates easily. Within a small change in temperature, it's able to evaporate. So what happens? The pump removes the vapor into the lower coil outside the cabinet, where it is compressed and changed to liquid form. So the vapor is now changed to liquid form. Then the evaporator and the condenser pipe are highly coiled. I've said that. And the reason why they are coiled is to increase the surface area for the absorption of heat. That is the condenser pipe. So yeah, the evaporator is for absorption of heat. Then the condenser is for the loss of heat. So they are highly coiled to increase the surface area. So evaporator is to increase the surface area for absorption of heat. Then the condenser pipe is to increase the surface area for the loss of heat. Then the pipes are made of good conductor of heat, for example, copper. And the reason why we use a good conductor of heat is to increase the thermal conductivity or heat conductivity into or out of the refrigerator. Then the copper fins also enhance heat loss to the surrounding the condenser pipe. So we are having two ways of enhancing thermal conductivity. One, use of copper fins. Then number two, making the pipes be of good conductor of heat. So those are the major parts that we have. So we will now look at this topic. These are revision questions on the same topic. Having gone through it, I believe we'll be able to, or you'll be able to answer all, if not all, then most of the questions in this case. So we have number one there, an electric heater rated 6,000 watts used to heat 1 kg of ice initially at -10 until all the ice turns to steam. Given that the latent heat of fusion is that, specific capacity of ice is that, specific heat capacity of water is that, and latent heat of vaporization of water is that, calculate the minimum time required for this activity. So equate heat given out by the heater, which is PT, is equal to heat absorbed by the ice. There is the ice changing from -10 to 0, the one melting, then 0 to 100, then the one vaporizing. Number two, explain why burn from steam of boiling water is more severe than that of water itself. Steam is more severe. Yeah, the reason is steam has an additional quantity of heat called latent heat of vaporization. So it has more heat content compared to water. So that's why a burn from steam is more severe than a burn from hot water. Then number B, an energy saving stove when burning steadily has an efficiency of 60. The stove melts 0.03 kg of ice at 0 degrees Celsius in 180 seconds. Calculate the power rating of the stove. So power rating is just the same as power. So you get the power either in joules second or in watts. The heat energy wasted by the stove. Once you have power, you can get energy because heat energy is power times time. Number 3, an immersion heater rated 90 watts is placed in a liquid of mass 2 kg. When the heater is switched on for 15 minutes, the temperature of the liquid rises from 20 to 30, determining specific heat capacity of the liquid. So you equate it given out by the heater to heat absorbed by the liquid, and you substitute and get the value of C, the specific heat capacity of the liquid. Factors that will raise the temperature, the boiling point of a liquid beyond or above 100 degrees Celsius. So of the 2 factors that we learned, look at how they can increase the boiling point. Number 5 states what's meant by that. That is defining specific latent heat of vaporization. Number B, in an experiment determining specific heat capacity of vaporization of water, steam at 100 degrees Celsius is passed into water containing a well-lagged copper calorimeter. The following measurements were taken. So you have mass of calorimeter, initial mass of water, we have final mass of calorimeter plus water plus condensed steam, final temperature of the mixture. Then we have those constants given there. So they want mass of condensed steam, heat gained by the calorimeter and water. Given that, hence specific latent heat of vaporization, not evaporation of steam. Write an expression for heat given out by steam. Then determine the value of L. Then number 6, a heating element rated 2.5 kilowatts is used to raise the temperature of 3.0 kg of water through 50 degrees Celsius. Calculate the time required to affect this. Then you are given specific heat capacity for water. State 2 factors that affect melting point of ice. Lastly, number 8, steam of mass 3.0 grams at 100 degrees Celsius is passed into water of mass 400 grams at 10 degrees Celsius. The final temperature of the mixture is T. The container absorbs negligible heat, so meaning we will not include the heat absorbed by the container. Then you are given those constants. Derive an expression for the heat lost by steam as it condenses to water at temperature T. Derive an expression for heat gained by the water. Then determine the value of T. So I believe those few examples will be able to give you enough exercise on this topic. So we will further be able to look at other topics, but for now, thank you for listening and for understanding what we've done through this topic.